Now the rest of our work will be on the client side, where I will need a function new counters on my perf hub to be able to process these messages from the server and get the updated performance counter information. So on perfhub.client, here's a new counters function that will take the counters from the server, and just like before, what I want to do is pass them over to the model. So perhaps a new method, add counters, where I can pass those counters off to the model. And now the model will need a method, add counters. That will be a function that will take some updated counters, and it needs to figure out what to do with them, where to store them. I know I'm going to need to store some values, so I will create a self.counters property, and that needs to be an observable array also. And the goal here is to take each of these counters that is coming from the server and create an entry in that array for each performance counter. I'm not going to make any assumptions about what performance counters are coming down, so if the server sends me 3, processor, paging, and disk, I want to have 3 entries in this array, one for processor, one for paging, one for disk. But if the server suddenly starts sending me a 4th one, I want to be able to add that 4th one to this observable array of counters. And to do that, the code will be just slightly messy, because when I get this list of updated counters, what I'll need to do is compare the counters that are there to what I have inside of this observable array. And if there's a match, because I'll keep track of them by name, if there's a match, I want to copy in the new values from these updated counters into the existing entries that I have. But if there's a brand new name there, some new performance counter, I'll need to add something new to this observable array. And since this array will be more than just an array of strings, because I'm going to need to keep track of the performance counter name and also the associated values, I think that calls for a new abstraction. So create a chart entry constructor function. Every chart entry has to have an associated name. And after I save off the this reference, I can say self.name equals that incoming name. Should this be observable? I don't think so, because once a chart entry is created with a given name, that name is never going to change. And I'll come back to that later and figure out how to store values. For right now, I want to find out if a given chart entry object is already in this counters collection, or if I need to create a new one. And I can do that by looping through the updated counters that I got back from the server and providing a function that will go off and process each one. With jQuery, when you use $.each, you're going to iterate over an array, in this case updated counters, and provide a function to process each item in that array. Each item will be passed in as update counter, the second variable. The first parameter there is index, which is the index of this particular item in the array that you're iterating through. And what I'll need to do for each update counter is find out if there is an existing entry in counters for that performance counter. And I can do that using a utility from Knockout, ko.utils, and there is a function in here, array first, that acts a bit like a link where statement. You tell it what sequence of items you want to iterate. In this case, I want to iterate through the counters collection that I have, and then I provided a function that, given each item in that collection, it's a predicate. It will return true or false. Is this the entry that you want or not? Once I format this so you can see everything, I could just say, let's return true if the counter name equals the updated counter .name. So if the server has given me a performance counter that I have already stored in the counters collection, then this will return true, and array first will give me that entry back. If it doesn't find anything, then entry will be falsy, and I'll have to create a new entry to add. So a new chart entry, whose name will be that updated counter name, and I'll need to walk up to my counters collection and push that entry into it. So it's now available inside of my collection. And after that's done, or if I do find an entry, what I need to do is tell that entry about the new value that came in this updated counter. So perhaps I could have a method on an entry called addValue, where I give it the updated counter.value. And where are name and value coming from? Well, remember in the PerfCounter service, we were creating objects with name and value properties, And it's those objects that are going to get serialized and appear here in the JavaScript. So just need to pull out the name and compare it to see if it's already in the counters collection that we have. And once we have an entry, pull out the value to update that entry with. So now my entries will need an add value method. Let me go ahead and create a prototype object to implement methods on chart entry. I know right now I need add value. That will be a function that takes an updated value. And now where do I store it? Well, this is where I have to start thinking about the actual implementation of the chart and what package I'm going to use to do charting. Turns out I already have something in mind. It's called smoothie charts. Unfortunately, smoothie charts is not available as a NuGet package, so I'll have to do this the old-fashioned way, which is download the file, or in this case, open the file in the browser, copy it, then come into Visual Studio, create a new script file. I'll call it smoothie, and paste that code in here. Now I just need to take smoothie, and I need to drag it into the index action so that this is available before our script. And the way smoothie charts works is that you have to associate a smoothie chart with a canvas that's in the DOM. And then every chart is going to have an associated time series, which is a collection of the data points that you want to draw into that canvas. And the reason it's called smoothie is because as it draws into that canvas, it's going to try to provide a fluid animation. It's intended to chart real-time data. And since I'm going to need a chart for each one of these chart entries, each one of these will be an individual chart, I can add another attribute here, which will store the associated smoothie chart. And when I create a smoothie chart, I can customize some of the settings. So when you're drawing the points, use 50 milliseconds per pixel. I also want to change the labels around just a little bit to make the font size a bit larger than the default, so 15 pixels. And every smoothie chart has to be associated with a time series. That's an abstraction defined in smoothie charts. So I could say self.timeSeries is a new time series. And it's that time series where I actually need to store the performance counter information. These incoming values need to be stored inside of this time series. But before I do that, I also have to associate it with smoothie chart. So I can say self.chart, let's add a time series, which will be this time series object I just created. And when I do this, I can also specify some options on how this should render. So I want the line width to be a little bit bigger than the default. And I want the stroke style to be the specific color, which I can specify as RGB. And let's make that red. Now when I do an add value, what add value really needs to do is to turn around and go to the time series and tell it to append that particular data point. Now a time series with smoothie, every value that you add expects to have a timestamp associated with it. And instead of trying to do something crazy like synchronize the server time with each one of these, I'll just in JavaScript use a timestamp that I can get from the date class in JavaScript. So just new date.getTime will give me a timestamp value that I can use and then push in the value. And now that I'm populating a time series with data, Smoothie will be able to graph that, but it does need a canvas to draw on. And what I need to do when we build out the UI is for each chart entry that I have, I'll need to create a canvas in the DOM. Then I'll need to locate that canvas and associate it with my smoothie chart. And the easiest way to do that might be to create a canvas that has an ID that is set to the name of my performance counter. That way I could write a method that can find that canvas and give it to smoothie chart so it can draw on it. Let me do that inside of a method called start. So start is a function that tells this chart entry to start drawing charts. This will need to be invoked after data binding with knockout because it's the data binding and knockout that will create the canvas in the DOM. And once the canvas is created, I should be able to find it and give it to smoothie chart. So inside of start, self equals this, and I'll create a canvas property that I can find by saying document.getElementById. Hopefully we will find a canvas element with an ID that is the same as our name. And when I have a reference to a canvas, then I can tell the chart to start streaming data to that canvas. And now I just need to make sure that start is called at the appropriate place. So where can start be called? Well, after I create a new entry, And I've added that entry to the counters collection, so Knockout has a chance to see that something has been added and manipulate the DOM and create a canvas for me. Then I should be able to invoke that start method. Now all I need is a little bit of UI inside of index.cshtml, and we should have charts on the screen. I'll put this, instead of in a third column, in a new row, so we have lots of horizontal space. I actually want a data binding expression here that says, for each of the counters that you find in the model, create a div with a class of column MD12 so it can take up the full width of the container. Let's have a header for each one, a header where I can data bind the text property to be the name of my chart entry, and then I need the canvas. A canvas is notoriously difficult to style the height and width, so I will hard code the numbers for now. We'll have an 800 pixel wide and 100 pixel tall canvas, and I just need to make sure that I set that ID so that we can locate this from the start method that was just implemented. We need to locate this by ID and associate a smoothie chart with it. So canvas, let's data bind attributes with Knockout. I want to data bind the ID and set it equal to the name. And with that, I'll do a build, and we can come over to the browser and refresh. And now I have some charts appearing on the screen. What Smoothie Chart will do as each coming data point arrives is adjust the chart, try to keep nice smooth lines. It allows a minimum value to appear here. So the minimum processor utilization that I'm seeing on this graph is about 31%. The maximum is 52%. Very little paging activity. Not much disk activity. This is measured as a percentage too. Perhaps something I could do to change that is launch a new instance of Visual Studio. There we can see processor climbs up, paging climbs up, disk activity also increased. And this is what SignalR can do. Stream real-time data down to the client, where I can graph it, display it, give it off to the user, and provide them information that is up to date.